Okay, Jacob, I'm gonna give you this video because this is how I remember learning this subject. And I believe that if you you just go into Desmos and you set it up, it's a lot easier to understand, and then the question becomes a little bit less cryptic, less of an enigma to you. So basically what I've done is I just put this in vertex form, and I've put sliders for all these variables, and I've basically set it so it does nothing. Timesing the a is 1 doesn't do anything. Timesing something by 1 doesn't do anything. Adding 0 doesn't do anything. And adding 0 again doesn't do anything. So none of these variables do anything at this moment. And that's why you have your typical equation. You got your 0 squared is 0. And this is just y equals x squared. So you got your 0 squared is 0. 1, which is somewhere in here. 1 squared is 1. 2 squared is 4. And it's hitting all the points exactly as you'd expect. So I'm going to go over and see how each of these affect it. If I move, the easiest one is just this tagged on little plus at the end. If I just move this up to 1, what's going to happen? I'm going to go back, and if you look at the graph shape didn't change at all. It's as if it's just whoop, moving it up 1 point at every single point. All the points are exactly the same. They're just going to be 1 higher. So 0 squared is 0 plus the 1. 1 squared is 1 plus the 1 is 2. 2 squared is 4 plus the 1. That's going to hit 5 up above. So that kind of makes sense. So if I put this back down to 0, or if I go to -1, it will just move -1. So if you're just moving your equation up or down, you don't want to change the shape at all. That's what you're going to want to do. If you go over to the b, you might think, oh, it's going to do the same thing. I'm just adding the 1, so it might just go up 1. But let's see what happens when I add to the b. Okay, it's moving side to side. And what's even weirder is, and a little bit counterintuitive, is that when I add 1 to x, the equation moves to the left. Now let's think about why that is for a moment. So if I add 1 inside of these parentheses, then my 0 plus 1 is going to be 1. And what's 1 squared? 1. My -1 plus 1 is now going to be my 0. And my -2 is now going to be my -1, so it's going to be 1 again. So it's a little counterintuitive, but if you think about it, it makes sense that all the values you used to have are now the ones that you have when you would have had 1 more. So that's why it moves to the left, unlike the y, which is just, manipulating the final result. So if I subtract 1, it's going to move to the right, etc. Finally, if I go over to my a, and I make this, let's say, 2. Let's figure out what happens. If I go up to 2, you're going to notice that 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. So it's not scaling at the rate of the square, but every point has just gone higher up. And if this graph was upside down, it would have gotten lower down. It's just stretching it out. Every value is exaggerated. Every value is, just 2 times what it used to be. So it makes the entire thing look more jagged, more rigid, and it's going to reach a 2 times as high a point in the same amount of time. And then the last interesting thing you can do is what happens as this goes really, really low, less than 1, it gets flat, and you can think about the same thing. It's exaggerated, but in the opposite direction. It's each value is at the 1 is now going to hit the whatever the fraction is. So it's going to hit 0.1 at 1. So everything is just brought down and desaturated. But as I approach 0 and go to negative numbers, if I go to -1, everything is just going to be flipped upside down. Because really what you're doing is you're just multiplying this. You're just going to flip every single value. Now, your k value is still going to be unaffected because it's not multiplied by the negative value. So if I add 1k, it's still going to go up 1. If I subtract 1k, it's still going to go down 1. But you can see how the entire kind of phase of this thing is going to be dependent on the a value. And it kind of makes this cool little flapping bird motion as you go from -1 to 1. So that's kind of how each of these things factor into the vertex form. And it makes sense if you think about it algebraically. I doubt that you watched this whole video, but maybe you get something out of it.